Hello, my name is Jabari. I'm a senior at Fulton Science Academy, and this is my submission for this hackathon. Okay, my background is in computer science and artificial intelligence. I've been doing this stuff for around 3 years now, developing applications that has won multiple international awards, and now I'm submitting for this. And so the story behind this is a bit significant because my friends my dad's friend actually owns a hospital, and so I've been doing part-time work for this hospital for a long time now, generating algorithm software, artificial intelligence applications for this hospital. And I randomly stumbled onto this problem being claim denials, and I figured out that claim denials were actually costing the hospital quite a big significant sum of money. And I took this and I looked at other hospitals in the area, and I looked at other hospitals nationwide, and I figured out this was a huge issue. Statistically speaking, they cost anywhere from 1 to 5% of the total net revenue of a hospital, which in aggregate of all the hospitals in the United States costs over $262 billion. Okay, that's a pretty significant sum of money, which is really just um, wasted. And I wanted to make a project that can meaningfully make a difference in this healthcare challenge. So for this hackathon, even if this hackathon didn't exist, I would have chose Cynthia. It was literally the best one for the scenario, for the best data for my problem. I checked other ones online. This was literally the best one. I'm not even joking, but obviously it wasn't perfect because it did not contain realistic revenues, or it didn't even contain revenue data at all, which is why I had to synthetically create financial data. But this financial data was based on statistics from my hospital and from hospitals around the United States, which is why it's extremely accurate. Additionally, I'm going to take you through this process of data conversion to graph structure. Keep in mind, I will be showing the code momentarily. I just want to get through the talking points for now. So the node types are patients, encounters, diagnosis, procedures, claims, billing codes, and payments. A little bit more on the patients is that's mainly consists of information on demographic risk scores, and insurance details. Then their edge types include patient encounter, encounter diagnosis, encounter procedure, encounter claim, encounter billing, and claim payment. The conversion process took many steps. First was obviously data loading from Cynthia. Um, I think I'm saying that right. Financial data generation, which is creating the realistic financial data revenue cycle or revenue data. Graph construction using Network X, creating nodes, and relationship mapping, kind of obvious. And then processing the data to ARANGODB by first establishing connection, collection creation, graph definition, data transfer, and finally validation. Now, agentic AI app architecture and implementation, the core of the solution was this agentic application that dynamically processed natural language queries about the healthcare revenue. So first, how it works is a query router, then execution pathways, path one being AQL queries, path two being GPU accelerated analytics, and path three being hybrid execution. And obviously the multi-hop reasoning agent, which was a key innovation in this project. The primary tools used was ArangoDB, NetworkX, LangChain, Graph, ChatGPT 4, D3.js, Fast API for API endpoints, Gradio for the interactive interface. And so I want to drive this point home because this is an actually important app. Like this hospital I'm going to use actually uses it and will continue to use it. They love this product, and I will be expanding it to other hospitals in the area, slowly improving my product over time because they actually get to see a working graph, and it looks and it feels amazing, a lot better than what they had beforehand. And so I really think that this project can influence so many hospitals, save so much money that otherwise would have been lost for really no reason, and it'll increase potentially 40 to 60% reduction in avoidable denials. That's based on the current hospital I'm working on, based on their statistics, and based on new ones as they continue to use it. And this will result in over time a larger use case. Now let's get on to the code.
Here's the actual Jupyter notebook. As you can see, I did not use the template, but I did use, basically the template. Well, okay, so here's just installing dependencies. Here's checking. Step 2 is checking if you're on a MacBook, and if you're, if you have a Windows machine and GPU and whatnot. I would like you to pay attention to this line of code right here, as it's for GPU specific packages for NVIDIA's acceleration. Okay, so right here is data acquisition. Lines being lines 92 to 111 download synthetic healthcare data, and these download synthetic healthcare data, and basically reads the CSV files into pandas data frames, and here right here, and and this is some sample data from the Cynthia and stuff, and I think you already know that, so I'm just gonna skip ahead. Okay, so right here is well, step 3 and 4 is really data acquisition, and I think we should just go to step 5. Okay, step 5 is the actual creation of the graph. Here, there's the patient nodes, there's the counter nodes, diagnostic nodes / condition nodes, claim nodes. I mean, I already explained it previously, and so I'll just be repeating myself. But here is okay. So here's a bit of data. Here's the edges and node counts, and here's a sample of the graph. See, right here, if a healthcare professional was looking at this, they could immediately notice the purple parts, and say, oh, these are the edge cases. And graphs looks different on different occasions, but yeah, it's quite easy to look at. And I've talked to healthcare professionals, and they said this is an amazing tool to work with. Yeah, and so now step 7 is ARANGODB integration. Essentially, there's a make. Oh crap! There's this function right here, which prepares the graph data for database storage, and yeah, there's just graph creation. Most of the comments that I did were actually are self-explanatory here, and yeah, okay, and so here is actually the cool part. Okay, so I already asked this question, but I'll submit it again just to show you guys I'm not faking it or something. Right here, right? See. Okay, right here. I just asked something that was based on the data, and it gave me a clear response. Okay, Google, stop. Sorry, I apologize for that. Yeah, but it gave me a clear response. I think this is a one of the most significant tools in this app entirely. Then here's the graph rag implementation. We have this that basically is responsible for direct data queries, and we have the run graph analytics, which is responsible for for network analysis algorithms, and other logic. And here's just the project summary. And yeah, I thank you for your time. This is pretty much it. Thank you for listening, and I am very thankful that you put this hackathon together because I learned so much.